Hello everyone. So in this video, as I told you, till the previous video we have covered all the types of questions that are framed on HCF and LCM. So now from this video we will be doing some practice sets, like we will be seeing all the types that we had seen in our previous videos. If you haven't checked them out, then please go and check them out. So we'll be just doing the practice now of all the things that we have seen previously. Okay, so this is a practice set 1 and my first question is, how many pairs of positive integers x and y exist such that HCF of x and y is 35 and sum of x and y is 1085. Okay, so we had seen this type of question in our previous videos. We know that what is n1 here. If n1 is my first number, then the value of n1 is AH, where A is the ratio and H is the HCF, right? We had seen this. And what will be the second number? It will be BH. B is my ratio and H is the HCF. Okay, we'll just revise the concept. Like if there are two numbers n1 and n2, okay, such that n1 can be written as A into H and n2 can be written as B into H, then A and B are two co-prime numbers, okay, and H is the HCF. This concept we had seen in our previous video, so I'm just revising the things. Okay, take it as a revision. So if n1 can be written as AH and n2 can be written as BH, then A and B are my co-prime numbers. A and B are some co-prime numbers such that I can write my first number as A into H and the second number as B into H, where H is the HCF of n1 and n2. Okay, so the value of HCF is given to me, the value of H is being given to me as 35, and they have given you the sum of the numbers, the sum of n1 and n2, that is 1085. Okay, so if I write this n1 and n2 in terms of AH and BH, how can I write? If my n1 is AH, then A into H plus n2 is BH, so B into H is equal to 1085, right? I can write it like this. This implies that A plus B into H is 1085. Okay, now putting the value of H in the equation, I will put the value of H, that is 35. Now I can get the value of A plus B. So what is the value of A plus B? 1085 upon 35 divided by 5. 5 sevens are 35, 5 twos are 10, 5 ones are 5, 5 sevens are 35. Now will it be divisible by 7? Yes. 7 threes are 21 and 7 ones are 7. So we got 31 as the value of A plus B. Okay, so A and B are any co-prime numbers such that my first number can be written as the product of A into the HCF and the second number can be written as the product of B and the HCF. Also, if you just divide this n1 by n2, what you will get? AH upon BH, so the H cancels out, A is to B. So you can also say that it is basically the ratio of n1 and n2, A upon B, right? So now we got the value for A plus B, that it is 31. Now if I find out that how many values for A and B are there which are satisfying this condition, A plus B is equal to 31. So I need to find the values of A and B which are satisfying this particular condition, and that many pairs I will have. Why? Because n1 is AH and n2 is BH. Okay, A and B are connected with n1 and n2. So if you find out the number of pairs of A and B satisfying this condition, that many only will be the number of n1 and n2. Okay, let's see it You'll understand more clearly after we find out the value for A and B. So let's first find out the values for A and B. Okay, so we will do that by hit and trial. We start with 1. So if my 1 is, say, if my A is 1, then B will be 30. The sum will be 31, isn't it? 30 plus 1 is 31. Then what else? If I take A as 2, then my B will be 29. 29 plus 2 will give me 31. Then when my A is 3, I will get here 28. 28 plus 3 is 31 and so on. If A is 4, then this is 27. 27 plus 4 is 31. Then we'll have 5. So 5 plus 26 is 31. This way we'll keep on doing. Okay, we will get till, like, we'll get 6, 7, 8 and here we'll get 25. You can see the pattern. Here it is reducing by 1 and here it is increasing by 1, right? So 24, then 8, 23, then 9, 22, then we'll have 10. I'm writing here after this because I don't have the place there. So 10 and 21, then we'll have 11 and 20, then we'll have 12 and 19, 13 and 18, then 14, 17 and 15, and here I will have 16. Okay, 19, 18, 17, 16, 13, 14, 15. Okay, then next I will have 16 and 15. Now see this, till here I was getting different pairs, but from this onwards, from 16 and 15 onwards, the pair are going to be repeated. See here, just the order has changed, but that doesn't, it is not a different pair, you see. Here we have 15 and 16, here we have 16 and 15. So it is the same pair that we have taken here, just the order has changed. So we will not take this, okay. Repeated pairs should not be considered because that is one and the same thing. And you will see that from here onwards, from 16 and 15 onwards, all pairs are going to be repeated because next pair that you are going to get will be 17 and 14, isn't it? Which we have already taken. Similarly, the next will be 18 and 13, which again we have taken. Then it will be 19 and 12, which again we have taken. So just the order is changed, but from here till 30 and 1, you are again going to get all these pairs, just the order is going to change. So we don't want the repeated pairs. Thus, we will take till here only, because after this the pairs will just change in order, but they are going to be the same pairs from here onwards, from 16 onwards, okay. So how many values sorry, my throat is a bit I got a cold, so my voice is not that good today. So where were we? We had seen till 15, 16, okay. So now what we will do is, we will check that since A and B have to be co-prime, from these pairs that we found, okay, the valid pairs that we found, we are not considering the repeated ones, so I will just rub this. Okay, so these pairs that we found, now let's see which one are co-primes, because A and B have to be co-prime between each other. So as you can see, you will find that all of these pairs are co-prime. 1 and 30 are co-prime, 2 and 29 are co-prime. 29 is a prime number, so obviously 2 and 29 will be co-prime. Similarly, 3 is prime number, so 3 and 28 are co-prime. 4 and 27 won't have any common numbers between them, so they both are also co-prime. 5 and 26 will be co-prime. 6 and 25, 7 and 24. You see, if you check, then all these pairs are co-prime. Therefore, all these pairs are possible for A and B. Okay, now let's count how many pairs are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have got here 15 pairs of A and B, and therefore I will have 15 pairs of N1 and N2, because N1 and N2 is nothing but AH and BH. So as you will keep putting the values of A and B, since there are 15 pairs of A and B, so when you will put that pairs, suppose I took this pair 1 and 30, so I'll put the value of A as 1 and I will put the value of B as 30. So I'll put the value of H as 35. Okay, so what will be my N1 then? For AH, it will be N1 will be 1 into 35, which is 35. And what will be the value of N2? I have put B as, for 1, B is 30. So 30 into H, which is 35. So I will get some number here like 3 5s are 15, 3 3s are 9 and 1 10, 1050. So you see I got one pair of N1 and N2. This is one possible pair of N1 and N2 which is going to give me the HCF 35, and the sum of X and Y is going to be 1085. You can even you can cross check also. Okay, if I try to find out the HCF of these two numbers, okay, 35 and 1050, you can see that we can apply reduction method to find the HCF. If I divide it by 5, I will get 7. 5 7s are 35, 5 2s are 10, 5 1s are 5 and 0. 210. Then these two can be divided by 7, right? So I'll get 1 and I will get 30 here. From 30 and 1, my HCF will be 1. And for the changes that I made, I'll compensate. Since I divided by 7, I'll multiply by 7. Since I divided by 5, I multiply by 5. So I got 35. So see, I got the HCF 35. And if you find out the sum of these two numbers, 1050 and 35, it is going to be 5, 5 and 3, 8, and C. The sum is 1085. So 35 and 1050 is one of the possible pairs. Similarly, if you take this pair of A and B and you put the value of A as 2 here, then my N1 will be 2 into 35, and for the value of A is, when the value of A is 2, the B will be 29. So 29 into 35, whatever we will get for after multiplying these two. Okay, for example, here I am going to get 70 and here I will get some value. So that is going to be another pair of 70, and whatever the result that I am going to get here, that will be the another pair which is going to give me HCF 35, and the sum of this 70 and this number is going to be 1085. Similarly, if I take the third pair, I put the value of A as 3 and the value of B as 28, H will be 35, then I will get the third pair of N1 and N2 which will give me HCF 35 and sum 1085. So this way, by putting the values of A and B, now you must have understood that since there are 15 pairs of A and B, we will get 15 pairs of N1 and N2, because N1 and N2 are nothing but the product of AH and BH, right? They are the product of AH and BH respectively. That's why as many pairs are there for A and B, those many only will be the pairs of N1 and N2. So we got 15 pairs. Therefore, there will be 15 pairs of N1 and N2 which are going to give me the HCF as 35, and the sum of the numbers will be 1085. And that only it is asking me in the question, like how many pairs of positive integers exist such that their HCF is 35 and sum is. So 15 pairs of positive integers, 15 pairs of N1 and N2 will be there, which will give you the HCF 35, and sum of the N1 and N2 will be 1085. So this is how we find out. Okay. So this was my first question. Now let's move on to the next question. Sorry for the delay, but it takes some time to just load the slides. Okay, so here we have our second question. Sorry, what happened? Okay, so here we have our question. The LCM of two numbers is 48. The ratio is 2:3. Then what is the sum of the numbers? Okay, this time I am going to try the blue pen because everything in black gets very messy and it's sometimes difficult to understand where we had the question and where we have the answer. Okay, so the LCM of two numbers is 48 and the ratio is 2:3. Again, as I told you in the previous previous question also, that N1 can be written as AH and N2 can be written as BH. Okay, why it is acting like that? Can I use red pen? See, N1 is AH and N2 is BH. So what it is saying, that I have told you A and B are basically what? A and B are numbers which are co-prime numbers. Okay, and you can write the N1 and N2 as AH and BH. What are N1 and N2? These two numbers that we are talking about. Okay, whatever numbers we are talking about in the question, those are N1 and N2. Okay, so if N1 and N2 are my numbers and A and B are two co-prime numbers, okay, then I can write N1 as the product of AH and N2 as the product of BH, where H is the HCF of N1 and N2. Okay, this is the concept. Okay, so it is saying that LCM of the numbers is 48. So the LCM of my N1 and N2 has been given to me as 48. Okay, so now if I multiply N1 and N2, okay, this concept also we have discussed in previous videos. If we multiply them, then putting the values AH and BH, what we will get? N1 is AH and N2 is BH. So N1 into AH into BH, it will be, now this will be ABH square. Okay, so the product of N1 and N2 will come out to be ABH square. Now what we can do is that we also know that product of two numbers is actually the product of, is equal to, we know this formula, okay, that product of HCF into the product of HCF and LCM, you can simply write like the product of LCM and HCF, that is HCF into LCM of two numbers, is equal to the product of the numbers. This formula we know, okay, that HCF and LCM of two numbers, the product of the LCM and HCF of two numbers is equal to the product of the numbers, right? So the product of the numbers, that is N1 and N2, is ABH square here. So this will be equal to the product of HCM and this will be the product of HCF and LCM of N1 and N2 from this formula, right? So if my HCF is H and if my LCM is a small l, then I can write it as ABH square is equal to H into L, because product of the numbers, that is product of N1 and N2, which is ABH square, will be equal to the product of the HCF and LCM of N1 and N2, which are H and L. So we can write this from here, H and H will cancel and what will be left with? ABH is equal to L. This formula we had seen in previous videos. So again I have revised this formula, like I have again repeated this so that you get a revision. So L will be ABH. Okay, now L has been given to me as 48 in the question, so I can put the values here, like, and the ratio has been given to me as 2:3. So what is the ratio here? Ratio is nothing but the value of A and B, because A and B are my ratio, isn't it? Because when you do n upon n1 upon n2, the h is going to cancel and you will have A upon B. So A upon B is nothing but n1 ratio n2 only. Okay, and that ratio only is given to you over here. The ratio is 2:3, means the ratio of the numbers is 2:3. That is n1:n2 has been given to you as 2:3, and n1 upon n2 is nothing but A upon B, right? Because the h is going to cancel out. Therefore, this 2:3 is nothing but the value of A and B. So I have A as 2, I have B as 3, and I have L as 48. So put all those value in this equation. What you will get is 2 into 3 into h is going to be equals to 48. So what will be the value of h then? 48 upon 2 3s are 6. So 6 8s are 48. Okay, so I got the value of h as 8. My HCF is 8 therefore. So now when I got the value of the HCF, then I have told you that if the ratio of two numbers is given to you and the HCF is given to you, then the number can be found, you can find out the number by multiplying the HCF with the ratio, isn't it? And also the other way around, that we already know that n1 is actually A into h. So we have the value of A and we have the value of h. So n1 comes out to be 16. Multiplying the h with the ratio or simply doing AH, it's the same thing. Now you must understand that why we multiply h with the ratio. It goes with this concept only, because n1 is AH and n2 is BH. So B is 3 and h we have found out as 8. So 24. So what are my numbers? 16 and 24 are my numbers. What will be the sum of the numbers? Just add them. So you will get 6 and 4 10 and 2 and 1 3 and 1 4. So 40 is my answer. The sum of numbers is 40. Okay, clear? So this was the second question. Now let's move on to the third question. Okay, so the third question is like, a heap of stones can be made into group of 21. When made into group of 16, 20, 25 and 45, there are 3 stones left in each case. How many stones at least can be there in the heap? Okay, so this is a very good question. Let's see how to solve this. So when it is made into groups, this heap of stone, when it is made into group of 16, 20, 25 and 45, so 3 stones are left in each case. Now I told you in my previous videos that groups means LCM. Whenever, this is a trick, this is a, you can say, hint, that whenever if we are talking about groups, it points to LCM. Okay, so you will find out the LCM of 16, 20, 25 and 45. Why we are doing that? Why we are finding out the LCM of these? Because LCM means what? LCM means the lowest common multiple. That is, whatever LCM we will get of these numbers, that LCM or that number is going to be divisible by all of these numbers. Okay, that's why. Okay, so first let's find out the LCM, then you will understand. Okay, first just find out, then I'll explain why we did it. So 16, 20, 25 and 45. Let's find it out. 25 and 45. 2 8s are 16, 2 10s are 20. Then we'll have again 2 4s are 8, 2 5s are 10. Then again 2 2s are 4, 5, 25, 45. And then again 2 1 5 25 45. And then we'll have 5 5 1 1 5 9. Okay, then I'll have 3. Again, now I am left with 5 and 3. So at last I'll have 5 and 3. So what will be my LCM? 2 into 2 into 2 into 2 into 5 into 3 into 3. Okay, this 3 and 1 5 will also be there. So 5. Okay, so this calculates to 2 2s are 4 2s are 16 2s are 32 into 5 into 9 5s are 45. Okay, 2 5s are 10 and 2 3 5 2s are 10, 5 3s are 15 and 116 to 45. What we will get? 64 720. Okay, so 7200. Okay, 7200 is the LCM. All right, so 7200 stones must be there. There is some mistake. Okay, I'm really sorry. This here is 16. 2 2s are 4 2s are 8 2s are 16 actually, not 32. This here is actually 16, not 32. 2 2s are 4 2s are 8 2s are 16. So this is not 32. This is actually 16. So 16 into 5 is nothing but 80. So we'll have 80 into 45. Okay. So we will have 80 into 45. This is wrong. I'll cut this out. Now what will be 8 5s are 40, 8 4s are 32 and 4 is 3600. So my LCM is 3600, not 7200. So 3600 is a number which is divisible by 16, 20, 25 and 45. Okay, that is, if there are 3600 stones, you can draw them in the group of 16, 20, 25 and 45. That is the meaning of it. Okay, if all these numbers, since 3600 is the LCM of all these numbers, means all these numbers can divide 3600. Okay, lowest common multiple. Multiple means a number which is divisible by the given numbers. Okay, the multiple of 16 means any number which is divisible by 16. Multiple of 20 means a number which is divisible by 20. Therefore, LCM of all these numbers is a number which will be divisible by all these numbers, right? So if 3600 is divisible by all of them, it means that 3600 can be drawn into the groups of 16 or 20 or 25 or 45. Okay, you can group the 3600 stones. If there are 3600 stones, you can group them either in a group of 16 stones. You can put like 16 stones like this. You can put all the 3600 stones in the group of 16. Similarly, if you want, you can put them in the group of 20, or you can put them in the group of 25, all of them into groups of 25, right? This is the meaning of it. But here it is saying, in the question it is saying that when it is made into group of 16, 20, 25 and 45, 3 stones are left in each case. Means it is saying that you are not completely able to form the groups completely. 3 stones are left in each case. That is, if you are making the groups of 16, then what will happen at the end, after you have made all the groups, what will happen? 3 stones will be left out. They will not be formed into the group of 16. Or if you are making the groups of 20, then again 3 stones will be left at the end. They are not going into the group of 20. So it means that my number is not 3600, but it will be of the form Okay, let me rub this. The number is going to be of form 3600K plus 3. Okay. The number of stones in the heap are going to be 3600K plus 3, because if the number of stones are 3600, then they will be completely drawn into the groups of 16 or 20 or 25 or 45, because 3600 is LCM of these numbers. So 3600 will be completely divisible by these numbers. So if there would have been 3600 stones, then we will be able to completely draw them into the group of 16, 20, 25 and 45. No stones will be left. But in the question it is saying that 3 stones are left, which means that there are not 3600 stones. Okay. In the question, since 3 stones are left, therefore the heap doesn't contain 3600 stones, but it contains 3600K plus 3 stones. Then only 3 stones will be left in each case, because if there would have been 3600 stones, then 3600 is completely divisible by these numbers. So no stone would have been left if we were drawing them into the groups of 16, 20, 25 or 45, right? But since 3 stones are left, therefore the number of stones are not going to be 3600, but 3600K plus 3. What is the meaning of 3600K? It means that any multiple of 3600. This part, see, whatever is the LCM, if you are going to multiply it by any number K, this part also, this number, this 3600K again is going to be divisible by all these numbers, isn't it? Because 3600K is again a multiple of 3600, and since 3600 is divisible by these numbers, therefore 3600K will also be divisible by these numbers. So this part, this 3600K part will always be divisible by these numbers. But since you have done plus 3 here, so this plus 3 will always be remaining as the extra part. That is, it will account for these 3 stones that are left out. Therefore, the heap consists of 3600K plus 3 stones. Why plus 3? Because it is saying that 3 stones are left in each case. 3600 is completely divisible by these numbers. Okay, but always 3 stones will be left because we have done plus 3 here. Therefore, the heap is going to contain these many stones, so that 3 stones are always left out. After making the groups of 16 or 20 or 25 or 45, always 3 stones are going to be left if there are 3600K plus 3 stones in the group. Okay. Now it is saying that I need to find this only, how many stones at least can be there in the heap. So it is asking you that in the heap how many stones can be there. At least means minimum number of, and minimum means LCM only, lowest common factor, isn't it? So minimum number of stones we have to find, how many can be there. So we simply need to find out the value of this 3600 plus 3, because I told you that the number of stones in the heap will be 3600K plus 3. Then only when they are drawn into these groups, then 3 stones will be left, because we have done plus 3 here. This part will get completely divisible because it is the multiple of the LCM of these numbers, but always 3 stones will be left because we have added 3 to this 3600K. Okay. Now it is also saying you in the question, it is telling you that heap of stone can be made into group of 21. Means that this number, this 3600K plus 3 is completely divisible by 21, because first thing that we found out is that the heap must be containing 3600K plus 3 stones. Okay. We figured this much that the heap is containing 3600K plus 3 stones. Why? Because when we are drawing it into the groups of 16, 20, 25 and 45, 3 stones are always left out. Therefore, the number of stones in the heap must be 3600k plus 3, because 3600k will be completely divisible by these numbers and 3 stones will be left out as we have done plus 3 here. So, the heap will be containing these many stones according to this statement. Okay. But it is again saying that the heap of stone can be made into group of 21, which means this heap of stones, which is containing 3600k plus 3 stones, it can be drawn into group of 21, means it is completely divisible by 21. It can be made into group of 21 means it is completely divisible by 21. No stones are left when we are drawing this heap into groups of 21. Because they would have given that in the question if any stones were left. So they can be made into group of 21 means they can be completely drawn into groups of 21 and no stone is left. That means 3600k plus 3 is completely divisible by 21. Okay. Now, see this. When you are dividing this 3600k plus 3 by 21, there will be some remainder. Okay, now once I am saying that it is completely divisible, then I am saying there will be some remainder. So that remainder only we need to remove, because it must be completely divisible by 21, because the heap can be drawn into group of 21 means it has to be completely divisible by 21. For making it completely divisible by 21 only, we are trying to find out the remainder and then we will remove that remainder. Okay, let's do that and see. In this case, what will be the remainder? If I divide, let's divide like separately. First, we will see for 3600k by 21. So just divide 3600 by 21 and find out the remainder. So 21 ones are 21. Here you will be left with 5 and 1 and 150. Okay. Now 21, I think it will go 5 ones are 5, 5 twos are 10. 6, 7, I think it will go 7 times. Okay, so 7 times, wait, let me rub this. This is okay. So it will go 7 times. 7 ones are 7 and 7 twos are 14. Now we'll be left with 3 and 0. Again it will go 1 times and you will get 21 here. You will be left with 9. Okay, so 9 is left as the remainder on dividing 3600 by 21. So for dividing this 3600k part by 21, what is the remainder that we are getting? 9k. Just put k with it because we have 3600k here. So for this part, the remainder is 9k. What will be the remainder for 3 by 21? If I divide 3 by 21, what will be the remainder? It will go 0 times and 3 will be the remainder, so plus 3. So this is my remainder when I am dividing 3600k plus 3 by 21. But there should be no remainder, right? There should be no remainder as this number of stones in the heap is completely divisible by 21. It can be completely drawn into the groups of 21. So this has to be completely divisible by 21. So there should be no remainder. Which means that 9k plus 3 must be a number divisible by 21. If we find out such a value of 9k plus 3 which is divisible by 21, then this remainder also will get divisible by 21 and therefore there will be no remainder left. Isn't it? This 9k plus 3 is given as the remainder when we are dividing 3600k plus 3 by 21. But since the heap can be drawn into group of 21, there should be no remainder. This number should be completely divisible by 21. Therefore, the remainder part should not exist. But here we are getting remainder of 9k plus 3. Therefore, I need to find out such a value of 9k plus 3 that it also gets divisible by 21. Then there will be no remainder. Okay, let's see that, then you will understand more. So we will do by hit and trial. We'll start from k is equal to 1. Just try putting values for k. If I put k as 1, if I put the k as 1, what I will get? I will get 9 plus 3, that is 12. But we know that 12 won't be divisible by 21. In fact, 12 is smaller than 21. Now let's try and put k as 2. Then what we will get? 18 plus 3, which is 21 itself. Okay. 18 plus 3 is 21, and 21 is obviously divisible by 21. Okay, so if I put the value of k as 2, I am getting value of 9k plus 3 as 21, which is divisible by 21. So now our remainder is also divisible by 21, and therefore there will be no remainder, 0 remainder. And that is what we wanted. We wanted this number to be completely divisible by 21, and therefore we made the remainder also divisible by 21. So now there will be no remainder. So what will be the number of stones in the heap? Just put k as 2 in this number. So what you will get is 3600 into 2 will be 7200 plus 3, that is 7203. So there will be 7203 stones in the heap. If you want, you can cross check by dividing this 7203 by 21. It will be completely divisible by it. If you see, it will go, I think, 3 times. 3 ones are 3, 3 twos are 6. Here will be left with 90. And then it will go 4 times. 4 ones are 4 and 4 twos are 8. We'll be left with 63, right? 63. So again 3 times. So see, it is completely divisible by 21. That is, it can be drawn into the groups of 21. Okay, and you can also cross check that if you try to draw it into a group of 16 or 20 or 25, you will always get a remainder of 3. That is, 3 stones will be left. If I try to divide 7203 by 16, then what will happen? 16, 6 is, no, that will get more. So 16 5s is, okay, that is, sorry, not 16 5s, 16 4s is 64. Okay. Here I will be left with 8, 0. Now it is 16 5s are 80, and see, I am left with 3. 3 is left out, as is given in the question, that if we try to draw this heap into a group of 16, then we will be left with 3 stones. So see, if you try to draw this heap which is having 7203 stones, if you try to draw them into group of 16, that is, you are dividing it by 16, you are getting a remainder of 3. That is, 3 stones will be left. Okay, just to like show you, prove it to you again, I will do for 20 also. You can check for 25 and 45. I am doing for 20. 7203 if you see, then 23s are 60. We'll be left with 120 here, and that is 6 times 120. See, again you are left with 3. So if you try to draw it into if you try to draw this into group of 20, again we are left with 3 stones. So you see that it is completely divisible by 21, as is given in the question. That is, you can completely draw this 7203 into groups of 21. But if you try to draw it into group of 16 or 20 or 25 or 45, you will always get a remainder of 3. So there should be at least 7203 stones to fulfill these to fulfill this condition. So therefore there will be 72 sorry, what happened to this? So as you can see, so 7203 is my answer. There must be 7203 stones in the heap. Okay, then it will satisfy this condition that has been given in the question. It will be like we will be able to draw it into the groups of 21, and when we will try to draw it into the groups of 16, 20, 25 or 45, then it is going to leave remainder of 3. That is 3 stones will be left in each case. I think it must be clear to you now. First what we did, I will just repeat once again. First what we did, we found out the LCM of all these numbers. Now LCM will be a number which will be divisible by all these numbers, because LCM is nothing but the multiple of the numbers, right? So, but we don't want a number which is divisible by all of these, because if we get a number that is divisible by all of these, that was like we found out that the number was 3600, right? We found out that the LCM was 3600, but 3600 is completely divisible by these numbers. Okay, if there are 3600 stones in the heap, then you will be able to draw them into the group of 16, 20, 25 and 45, and no stones will be left. They will be completely drawn into the groups, because 3600 is completely divisible by these numbers, so no stones will be left. But here it is saying that 3 stones are left in each case, therefore we add 3 to the LCM, but not to the LCM, to 3600K. Okay, 3600K, because 3600K is the multiple of 3600. So this part will always be divisible by the given numbers, that is 16, 20, 25 and 45, but always we will be left with 3 stones as given in the question. Okay, so from here we have figured out that there must be 3600K plus 3 stones in the heap, so that when they are drawn into the group of 16 or 20 or 25 or 45, 3 stones will always be left out. Then also it is given in the question that this heap of stones which is containing this 3600 plus 3 stones, 3600K plus 3 stones is divisible by, it means it can be drawn into the groups of 21. Okay, drawn into the groups of 21 means it is this number, this 3600K plus 3 is completely divisible by 21. Okay, so we divided it by 21. We found out a remainder that came out to be 9K. Okay, that came out to be 9K plus 3, but there should be no remainder as 21 has to completely divide this number. So that's why we find out a value of 9K plus 3 such that it is completely divisible by 21. So we use hit and trial and we find out that K equals to 2 is giving me a value which is completely divisible by 21. That is, the value comes out to be 21 itself. Okay, so we have found out a value of the remainder which is completely divisible by 21. So now remainder also is completely divisible by 21. That is, there will be no remainder left now. So if you put K is equal to 2 in this number, in this 3600K plus 3, then you are going to get a number which will be completely divisible by 21. Okay, so finally we put K as 2 and we get the value of the number as 7203. Okay, so 7203 is completely divisible by 21 and it is leaving the remainder 3, that is 3 stones will be left if we try to draw it into the groups of 16, 20, 25 and 45. Okay, so I think this is clear and I am ending the video here. I had hoped to cover 5 questions, but I could not because this like only 3 questions have taken a lot of time. So I'll be continuing further in the coming videos. We'll continue with this practice set 1 only. 2 questions are still left. Since the video is getting very long, so I'm ending it here at with these 3 questions. Okay, if you like my video, then please like, share and subscribe my channel and comment also. And this is it for this video. Thank you. See you next time.